Hi Pre-Calc. Let's take a look at a lesson that is going to teach you about domains of functions. Okay, this is something very important. It's going to come up a lot, and I want to make sure we understand where the rules are coming from. The first thing we're going to do is take a look at some math problems. So I'd like for you to grab your calculator. Go ahead and get it and play along with me, please. Okay. If you get stuck on a test, you could always do stuff like this to help you figure out the rules. Okay. So if I have the square root of 12, the square root's in blue, the square root of 12, okay, is that possible? Okay, yep, we're getting about 3.46. I'll use squiggly equal signs because I'm rounding. What about the square root of negative 9? Okay, make sure it's the little negative sign down here from the bottom, okay, not the minus sign. And the calculator is saying the answer is 3i. Okay, if you're not getting I, maybe you don't have your imaginary numbers turned on. If you go to your mode, if you're in complex form right there, we could always turn it back to real form. Okay, so some of you may be getting an answer like this. Oh, non-real answer. They're imaginary. Okay, so the square root of a negative number, okay, cannot happen. Okay, it's imaginary. It's imaginary. So we're going to stop right there. How about the square root of 0? Do you think that can happen? All right, let's go see. If we do the square root of 0, oops, what did I type? The square root of 0 is a 0, okay? Because 0 times 0 does make 0, and so you can take the square root of 0. What kind of numbers can go in a radical? Okay, not negatives, positives, and 0. Okay, so no negatives. No negatives can go in a radical. You could put decimals, you could put fractions, you could put positive numbers, but not negatives. Okay, how about fractions? How about fractions? What kind of numbers can go in a denominator? Okay, 12 divided by 3. Well, I know that's a 4. Okay, so can positives go in numbers? Sure. Can you divide by a negative number? Well, 6 divided by negative 2 gives you negative 3. Yes, you could divide by a negative number. Can you divide by 0? No, right? You can't divide by 0. Let's see what the calculator says, just in case we ever get something like this. We'll know how he's communicating with us. Oh, error. Cannot divide by 0. Okay, so this is not allowed either. So what kind of numbers can go in a denominator? Not 0, but positives and negatives. Okay, not 0. But positives and negatives can. Positives and negatives can. And finally, let's take a look at these. These are radicals that are in a denominator. Okay, so it's kind of like these first two categories together. So if I have, let's quit right here, 1 divided by the square root of 4, okay, the answer is 0.5 or 1/2. Because radical 4 becomes a 2. What if I have a negative in that radical? I feel like we're kind of back over here again. This is not going to work, is it? 1 divided by the square root of negative 4? Yeah, not real answer. It's not working. Okay, you can't do that. You can't put the negative in the radical if it's in the numerator or the denominator. Now, what about this? Can I put 0 in a radical? Over here, I think we decided, yes, you could put 0 in the radical. But wait a minute, you can't put 0 in the denominator. Since that radical is now in the denominator, okay, that's not going to work. The calculator will help you with this, of course. If you type 1 divided by the square root of 0, what does he say? Oh, can't divide by 0. So this actually ends up being 1 divided by 0, and that's the problem with it. So when you have the radical in a denominator, okay, what kind of numbers can go in? Okay, positives, right? positives. Okay, we cannot have 0, and we cannot have negatives. So really, some people say, aren't there really only 2 cases? Case 3 is really just the first 2 put together. Okay, so how are we going to do domain rules algebraically for problems? Okay, so the first rule is for radicals. All right, so we're taking a look at expressions that are in a radical. Okay, so what you're going to do is you're going to take this expression, okay, and you're going to say, hey, expression, whatever the math problem is in there, that expression cannot be negative. It could be positive or it could be 0. So you're going to say you have to be greater than 0. Or you could be equal to 0. And that's how you set up the domain problem that you have to solve. All right, what if you're in a denominator? You find the expression that's in a denominator. Okay, it cannot be 0. It can be positives or negatives. Okay, all right, expression, you cannot be 0. So we'll use the cannot equal 0 sign. You solve those just like equal signs. And finally, what if your expression is in a radical and a denominator? Okay, so you find the expression. You cannot equal 0. So we're kind of like this. But we're also greater than 0, but not the equal part. Oh, not the equal part? Okay, then I'll say greater than 0. All right, I hope that makes sense with how we do this. When we have a problem, here's the steps. Okay, you find the expression in the radical or the denominator. So you find it, circle it. Okay. Then you write a mathematical equation or inequality representing the rule. Okay, so either that expression has to be greater than or equal to 0 or not equal to 0. Then you show good work in solving that inequality or equation. All right, first example. You always ask yourself the same thing. Do you see any radicals or do you see any denominators? Ooh, this is a numerator. Okay, numerators are fine. That's not a denominator. But right down here, okay, this expression, you find it, is in a radical and it happens to be in a denominator. Okay, found it. Step 2, you write it. So the quantity x plus 4 has to be something. He's restricted. Okay, if you're a radical in the denominator, we're case 3, a radical in the expression has to be greater than 0. Okay, I wrote the inequality. Step 3, solve this inequality. I will subtract 4 from both sides, okay, and x has to be greater than negative 4. Okay, so what is the domain? The domain is, okay, x's have to be greater than negative 4. All right, that's how you do domain problems algebraically. Let's keep going so you see a variety of things. Okay, there's a bunch of problems I want you to get lots of exposure so you know what to do. Problem A, okay, we're finding the domain algebraically. Do you see a radical? No. Do you see a denominator? No. Okay. Oh man, this is kind of weird. So there's no restrictions. There's no problems here. There's no problems. Okay, so what's the domain going to be? What kind of numbers can I put in? I can put in positives. I can put in negatives. I can put in 0. Okay, so the domain for this problem is going to be all reals. All real numbers are allowed in. There's another way to write this, okay? And it's the symbol for all reals. So you put 2 sticks really close together, okay? It's like writing an R, but 2 times, and then you finish off the R, okay? That's the symbol for all reals. Oh, well, that's easy. I only have to do it if I see radicals or denominators? Yes. Okay, problem B. I see a denominator. Find it. Okay, now we're going to write it. X squared minus 4. Okay, what's the problem with denominators? Denominators do not like 0. So I'm going to say cannot equal 0. Right? Now, how do you solve a problem that has a not equal sign? Just like an equal sign. Okay, so I'm going to go ahead and move the 4 to the other side. And then I'm going to square root both sides. And x cannot equal, oh, did you say plus or minus 2? Remember, when you have a squared power, there's going to be 2 answers. You could also solve this another way. Okay, you could also factor into x plus 2, x minus 2, okay, and you would get 2 answers that way. All right, but don't forget, when you have a squared power, there's 2 answers. Sometimes people forget the minus 1. Okay, now how are we going to say this? Okay, I asked for domain. What numbers can go in? And you said, not 2. Oh, well, what numbers can go in? Can the number 3 go in? Yeah. And the number 4 can go in. And the number 5. How am I going to say what numbers can go in? Okay, so remember, domain means values that are allowed. Values that are allowed in. What numbers are allowed in? You told me not to use these 2. That means all the other numbers in the world are allowed in. Okay, how do I say all other real numbers? That symbol right there. Okay, all real numbers, comma, comma. Okay, comma means except. Okay, all numbers except, not the numbers plus and minus 2. Okay, so the domain for this problem is going to be written like that. Okay, I didn't need to add the all reals because this would have had all reals. Okay, let's go do problem C. I see an expression that is in a radical, so I'm going to write it down. Hi, expression in a radical. Expression in a radical, what's that domain rule? Okay, it might be helpful to go back to your notes. If you have an expression in a radical, oh yeah, greater than or equal to 0. Greater than or equal to 0, not the negatives, right? But greater than or equal to 0. How do you solve an inequality? Okay, I'm going to go ahead and subtract 4 from both sides. All right. Now I will divide by a negative. Divide by a negative. So we're going to have, a positive 4/3. Hey, what happens when you solve an inequality? What do we have to do to this sign right here? Only when we divide by a negative do we have to flip this sign. Okay, so I think all numbers that are less than or equal to 4/3 are going to work in that problem. Okay, so what's the domain for this problem? Do I have to write all reals? No, we don't write all reals. Why not? Because domain is what values are allowed in. And I told you the numbers less than 4/3 are allowed in. Okay, I don't have to say all reals and then all the ones that are less than 4/3. Here I have to say these are allowed except these 2. Okay, so we don't put the double bar R when it's an inequality like that, only when it's a not equal, so that you actually say what is going in. So for example, a number that's less than 4/3 would be like the number 1, right? I think x equals 1 would be allowed in. Is that true? If 1 goes in here, is that going to work? Let's see. 4 minus 3 times 1. 4 minus 3 is a 1. Is that going to work in a radical? Yeah, you could do the square root of 1. Okay, square root of 1 is a 1. Yeah, that's going to work. Okay, I found the right numbers. But if we tried the number 10, it wouldn't work. 4 minus 30 would make a negative. Okay? All right, let's keep going. Problem D here. Problem D. Okay, so I look at the problem. Oh, I found an expression in a radical in a denominator. Okay, so I'm going to write that expression down. That expression, because it's in the bottom, cannot equal 0, but it's a radical, so it can't be negatives. So this one has to be positives. We're going to go ahead and subtract 4 from both sides and be greater than negative 4. Okay, so there's the domain. Do I add the double bar R? No, because I've already said what numbers we're going to use. We're going to use the numbers greater than negative 4. Letter E. Letter E. I'm looking for a radical. I don't see one. Looking for a denominator. I don't see one. Okay, if you don't see a radical or a denominator, what do we say for the answer? That's right. It's all real. All real. Okay, letter F. Sometimes they're fast, right? For letter F, I'm looking at the problem and I'm trying to find, oh, I see this little tiny denominator. Okay, so I write down the expression. Since he's in the denominator, denominators cannot equal 0. Okay, how do you solve this? It's already done. X cannot equal 0. Okay, so what is the domain? What numbers are you allowed to put in? Well, not 0. Okay, but what numbers can I put in? I won't use 0. I'll use all the other real numbers. All real numbers, comma, except don't use 0. So that's the domain. Getting the hang of it? Letter G. Letter G. I see a denominator. Okay? The denominator cannot equal 0. Okay? Now we're going to go ahead and solve this. Can you factor a sum of squares? Nope, it does not factor. I will move the 5 to the other side, make a negative, and then try square rooting. Okay? Can you square root a negative? It's not working. I can't factor. I can't square root. Okay, I'm trying to find what numbers to not use. I can't find any restrictions. Okay, I can't find, so x cannot equal, no restrictions. So what numbers am I going to use in this problem? I can't find any restrictions. Oh, well, if you can't find any problems, then that means you can use all reals. Really? Yeah, if you can't factor it and you can't square root it, that means there are no problems to be found. Wait, you're telling me I can put a negative number in here? What? If I put a negative number in right here, let's say x is negative 2. Negative 2 times negative 2 is positive 4 plus 5. There are no restrictions. All numbers are working. Letter M, I see an expression in a radical, okay? What is the inequality problem you write for this? Yeah, we're going to say greater than or equal to 0. And then we're going to add the 16 to the other side. So what numbers can you use? All numbers greater than or equal to 16. Do I have to say all reals? No, that's kind of redundant. You don't say all real numbers and then just the ones that are more than 16. You just leave it alone. Okay. Letter I. I see a similar expression here. He's quadratic in a denominator. So you take that expression. Remember the problem with denominators. Okay, denominators, okay, do not equal 0. Okay, so do not equal 0. Now we solve it. Okay? This is a difference of squares. So you can factor x plus 4, x minus 4. Okay. Oh, hang on. Don't forget to write not equals to 0. It's got to stay an equation. Okay, so now using the zero product property, x cannot equal negative 4 and x cannot equal positive 4. All right, so wait a minute. What numbers are we allowed to use? Don't use 4s. Okay, I won't, but what numbers should I use? You have to say all real numbers except those two. Okay, and that's the correct way to write the domain. Could you have square rooted this one? Sure. You could have taken the x squared, moved the 16 to the other side, Okay, and you could have square rooted him, and you would have gotten not equal. Okay, hopefully you would remember plus and minus 4, same thing. Then you would also have to say all real numbers except not plus minus 4. Okay, domain means what values are allowed in. Are allowed in. You can't just say not. You can't just say don't use those. What numbers are? All the other ones. Okay, and we don't have to say that with the greater than, because this one's already telling us use all x's greater than or equal to 16. All right, let's keep going here. Letter J, I see an expression in a radical. 9 minus x has to be greater than or equal to 0. I'll subtract the 9 from both sides. Negative x greater than or equal to negative 9, and then we will divide both sides by negative 1. Dividing by negative, we have to flip the sign. Flip the sign. So I think all numbers less than or equal to 9 would work. I don't think 10 would work. All the numbers less than 9. Like 2? Can I put 2 in right there? 9 minus 2? Sure, you could take the square root of 7. Okay, and this is how you write the domain. Letter K. Okay, I don't see a radical. I don't see a denominator. What is the domain for letter K? The domain is all real numbers. Any number you want can go in there. You can put a negative. You can put a positive. You can put 0. All numbers. Letter L. Letter L. I see a denominator. Okay, I see a denominator. Expressions in a denominator. Okay. What's the restriction on them? They cannot equal 0. Cannot equal 0. Remember, when you have fractions, okay, this is a no-no. Okay, you cannot be 0 down there. No, cannot equal 0. Let's see, let's add 14 to both sides. X cannot equal 14. Okay, I can't use 14. What can I use? All real numbers except 14. Okay, that's the domain. Letter M. Letter M, I see a denominator. Circle the denominator. Step 2, you write down the expression in the denominator. Now you have to think, what's the problem with denominators? Okay. Denominators do not want to equal 0. Do not equal 0. Okay. The not equal signs work just like the equal signs. We're going to factor them the same way. All right. Oh, factor. Oh, yay, factoring. All right. How does this quadratic factor? All right, let's see if you factored correctly. 2x times x is the right way to make 2x squared. And then 15's got to be a 3 and a 5, right? A 3 and a 5. If we put the 5 here, the outers are 10. If you put the 3 here, the inners are 3. 10 and 3 would perfectly make a 7 if this was minus 3 and positive 5. Okay. Then we'll use the zero product property. Okay, so for this first factor right here, x cannot equal 3 divided by 2. And then here, x cannot equal a negative 5. We just got to make sure we use not equal signs. All right, so we can't use 3 halves. We can't use negative 5. Those are the two problems, the two numbers that are going to cause a denominator to be 0. So we can't use those values, but we can use all other values except those two. You could try it. You could take negative 5, okay, and you'd have a problem, right? Letter M. Letter M. I see an expression that's in a radical. So I write down that expression, and if you are in a radical, you have to be greater than or equal to 0. Let's go ahead and subtract 23. 23 to the other side. Now he's negative. I'll divide both sides by negative to make them both positive. Oh, but when you divide by negative, flip the sign. Okay? You don't have to say all reals because this kind of already says all real numbers that are less than or equal to 23. All the numbers. If you looked at a number line, okay, and this was the number 23, you would be able to use 23 and all of these numbers that are less. Okay, so you've kind of already said all numbers, but you've said all the ones that work. Letter O. Okay, do you see a denominator here? Do you see a radical? No, I don't see a radical or a denominator. If you don't see either of those things, okay, the answer is all reals. That's it? Yeah, that's all you have to do, okay? This is an absolute value sign. So can you put negatives into absolute values? Sure. Can you put 0 in? Yes. Okay, so we don't have to worry about absolute value signs because remember, absolute value signs were not one of our restrictions. We only worry about radicals and denominators. Or radicals and denominators. Okay. Now, if this was in a denominator, that would be a different story. That would be a different problem. Okay. Letter P. Letter P. Let's take a look at, a denominator. Okay. X cubed minus 8 cannot equal 0. All right. How do we solve a cubed root? I'm going to go ahead and move it to the other side and say positive 8. Okay. And how do you get rid of a cube? We're going to cubed root it. We're going to cubed root it. The cubed root cancels with the cubic. Okay. And then we just get x. X cannot equal. And then with the cubed root, you're looking for something, something, something. Something that multiplies 3 times. 2 times 2 times 2 makes an 8. So x cannot equal 2. If you put a 2 in there, you're going to get a denominator that's a 0. That's bad. Okay, what numbers are you going to use then? All other numbers except 2. Like 1 and 3 and 4, but not 2. Letter Q. What is the domain for this cubic? All reals. All real numbers. I don't see a radical or a denominator. Okay, and the last one. I don't have a problem with numerators. It's when there's denominators. And he happens to be in a radical. Okay, so this problem right here cannot equal 0 and can't use negatives. So you're going to just stick with the positives. X is greater than 16. Done. Done. Okay. Can you algebraically find the domain of a function? Okay, I hope so. Can you find the difference quotient? That's a review from last time. Thanks, Pre-Calc.